New mirrors arrived and the construction resumed after a setback of 2 months. To get back on schedule was a daunting task, but armed with experience and determination, the team doubled their efforts in assembling and installing the parabolic troughs. Putting mirrors together is fairly simple. Building 5,760 parabolic troughs was a challenge. 4,000 parabolic troughs were in place. In the next 3 months, the team had to finish installing approximately 1,700 troughs to finish the plant in time for commissioning. Central to these operations is another expensive and complex piece of technology: the receiver tubes. These tubes are designed to trap the maximum amount of heat reflected by the mirrors.
This is the high-end product that actually absorbs the radiation coming in from the sun being reflected from the mirror into this. This has a property like it has a steel tube through which the STF is circulated.
Their construction involves the extremely difficult feat of welding glass with metal. This technology doesn't exist in India. The tubes at the plant are from Schott Glass, one of the only 2 companies in the world that manufacture them. These tubes reached the plant after covering a distance of more than 8,000 kilometers. Once they reached the site, 3 of them were welded together to form a single 12-meter long receiver tube. The team's target was to eventually install 17,280 of these receiver tubes. However, safely moving these tubes to the solar fields was a challenge. For their transportation, 8 custom-made carriers had to be fabricated locally, each with a capacity of 72 tubes. These thin tubes will carry 1,100 tons of heat transfer fluid, or HTF, through all 4 solar fields. This fluid will run through the 240 rows of solar collectors and heat up to a temperature of 393 degrees Celsius. This scalding liquid will then flow through seamless carbon steel pipelines. Clad and insulated with rock wool, these pipes will not let the fluid cool down. Keeping the plant's commissioning deadline in mind, this heat transfer fluid was ordered well in advance and arrived at Kandla Port, Gujarat, one of the largest ports in India.
This fluid is manufactured in the United States and is transferred by bulk shipment to India. Depending on the design of the concentrated solar power plant, the plant may require anywhere from 20 to 30 metric tons of fluid for every megawatt of power. In Godawari's case, their plant capacity was 50 megawatts, and we supplied approximately 1,100 tons of fluid.
This synthetic fluid must be stored at a temperature of 60 to 65 degrees Celsius and hence will remain here in these temperature-controlled shore tanks until the plant is ready. From the solar fields, the fluid will then flow to its ultimate destination, the heart of the solar plant, the power block. This steel structure, worth rupees 180 crores, is the place where the sun's heat will turn into 100% clean energy. It took a dedicated labor force of over 500 workers, working round the clock, nearly 6 months to complete this vital element of the plant. At its center lies the most expensive element, its raison d'être, the turbine. The 213-ton piece of machinery was shipped to India all the way from Sweden.
When you consider the size of the plant, you begin with turbine capacity, and then you back calculate all the other things that would be serving, like the steam generation required, and then the heat of the steam, and based on that the solar field is designed.
Before the turbine can begin power generation, the fluid needs to reach the steam generator. Supplied by Arlberg CSP, the steam generator weighs nearly 615 tons. Here, pipes containing HTF will exchange heat with 257 tons of water per hour, generating superheated steam up to the temperature of 385 degrees Celsius. This steam will then be used to power the turbine, which will then generate the precious megawatts. At the end of construction, each component of the plant will be fully automated using proprietary software from Rockwell Automation. Each piece of machinery, from the parabolic troughs to the turbine, will be controlled with a single click. When people come together to design the future of energy in India, it has to be ensured that their own energy doesn't run out.
Approximately 1,500 workers are working in this area, and it becomes very important for we people to create an environment so that the morale of everybody stays high and they can perform better.
And what better way to recharge than finding a family away from home? A family with which you can share your dreams, and friends with whom you can unwind and let go of the day's stress. Nok, a small Rajasthani village, which is fast becoming prosperous thanks to the newest addition to its neighborhood, Godavari Green Energy Limited.
गांव में गोदावरी कंपनी आई है तो बहुत अच्छा हुआ है। ये में बिजली उपलब्ध हो जाएगी तो माने भी सहयोग मिलेगा और गोदावरी में भी अच्छा है। कंपनी आई है तो लोग पेट भरते हैं, मजदूरी करते हैं, मजदूर लगते हैं।
For the families of Nok, the new jobs in the plant have brought new possibilities. The economic upliftment has empowered them to rise above the hard and unpredictable life of a daily wage worker and dream of a brighter future. Meet Raju and his brand new tractor. This is Raju's brother. This is their favorite ride, Raju's motorcycle. Raju wants his brother to grow up to be an engineer.
मेरे घर में 7 बच्चे और 2 लड़का। सबसे बड़ा बेटा है राजू। कंपनी में जाने से, मजदूरी करने से राजू का सुधार हो गया। मेरे को बहुत अच्छा लगता है।
Raju used to be a daily wage worker, but after securing a steady job at Godavari, he was able to secure a bank loan and purchase a tractor, and is now planning to fulfill a few more dreams.
जब से राजू भैया गोदावरी में काम करते हैं बहुत अच्छे हो गए, इसमें सुधार बहुत अच्छे आ गए। बहुत करते हैं, हमारे लिए गिफ्ट वगैरह बहुत लेके आते हैं, हमारा ख्याल रखते हैं।
अच्छी मजदूरी हो रही है, अच्छी कमा रहा हूँ। अब मेरे जून को शादी होने वाली है।
This morning, the sun is shining a little brighter on Godavari. Today, Raju has a very important task to perform. Amongst his other tasks at the plant, he will drive the last panel on the 4th solar field. Meanwhile at Kandla, the heat transfer fluid has been transferred from shore tanks onto 45 road ISO tanks of 24-ton capacity each. These road tanks are on their way to the plant site, crossing 2 states and covering a distance of nearly 700 kilometers. Today, after 18 months of work, the team is entering the final innings. They have assembled the parabolic troughs that will gather the sun's rays.
This is the last trough we are erecting, and this will complete our 120th loop.
चलो 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 चलो। घूम के आओ फटाफट। हाँ देख के खींच के रखो, खींच के रखो। बूम डाउन कर, बूम डाउन कर। खींच के रखो। चलो चलो। डाउन हुआ क्या इधर? दादा फिट हो गया यहाँ? डाउन ओके, बंद कराएं? ठीक है। आपको भी सर। Congratulations.
Thank you. So this was the last panel that we erected, and this completes our 120th loop. And with this, our solar field is complete.
Thus, the last jewel has been added to the centerpiece of this plant, the solar fields. In spite of being challenged at every step by both nature and technology, the team has met the deadline. In just 18 months, they have transformed hundreds of acres of barren land into state-of-the-art solar fields.
We are happy now, and our next step is to run the plant, start generating the megawatt. So I congratulate all of you, and let us look for the new target.
The fields are complete. The team's next challenge is to become the first of the 7 solar thermal power plants under the Jawaharlal Nehru National Solar Mission to generate power and to prove that in the long term, solar energy is a viable economic option. The heat transfer fluid has arrived from Kandla port just as the solar fields are ready. As soon as the fluid arrives, the team begins to empty the fluid from the road ISO tanks to the HDF expansion vessels. Once the heat transfer fluid is in the pipes, the pumps must be started to ensure that the fluid circulates throughout the fields. In keeping with internal deadlines, Mr. Avikal Dubey needs to have the HDF pumps up and running by tonight. It is proving to be a long night for Mr. Dubey and his team. They have been working ceaselessly with the sole agenda of having all 4 pumps running before sunrise. And just before dawn, the team meets with success.
हाँ चालू करें, फील्ड में है ना? One milestone you can say we have achieved, that we have given command from this DCS system and motor is started in field.
It is now time for the last major process before commissioning, air and steam blowing. In this process, the pipes that will carry the superheated steam to the turbines will be cleaned.
अभी एयर ब्लोइंग की एक्टिविटी चालू होने वाली है। नॉर्मल प्लांट्स में हम लोग स्टीम ब्लो करते हैं पाइपलाइंस को क्लीन करने के लिए। पाइपलाइंस में वेल्डिंग के टाइम में कुछ अंदर डिब्रीज होती हैं, वो डिब्रीज को निकालने के लिए हमको उसको क्लीन करना होता है पाइप को, टरबाइन को डैमेज होने से बचाने के लिए।
With air and steam blowing over, the team gets busy carrying out final checks and balances before commissioning. With so many components coming together, things can often go wrong. This time, it is the solar collecting elements.
We have put these solar panels in auto mode. They will automatically track the sun. Most of the panels are right now tracking. A few have a little communication problem, like there's a command that is generated from the DCS that comes to the local panels, and few of them have a little communication problem in the fiber optic cable or in the card. So our instrumentation guys are checking them. Once these defective panels are attended, the communication is set properly. It will be put on track mode automatically, and whole solar field will start tracking the sun together as a group.
These solar collecting elements will move approximately 18 degrees per hour to track the sun, their only fuel. All the key components of the plant are in place, and the destination of this remarkable journey is near. The day of commissioning approaches, the day when all these components will come together to generate power. The parabolic mirrors will focus the sun's rays onto the receiver tubes filled with heat transfer fluid. The HTF will then travel through all the solar collecting elements in a solar field, absorbing more and more heat. Eventually, its temperature will increase